Okay, here we are ready to start doing our tool paths for OP1. We have clicked on our OP1 view sheet. You can confirm down here the WCS is set to OP1, so is our C-plane, so is our T-plane, so we are ready to go. We're going to start out by area milling this top pocket. Hit the drop down, area mill. We're going to have stay inside because this is a pocket. We definitely want to stay inside on this one. We're going to pick our machining region. We're going to have construction plane set, and we're going to pick this pocket right here. We can preview the chains, make sure it's doing what we want. So once again, here's our toolpath type. It's an area mill. We can look over here. You can see our machining regions. We're staying inside. Don't need to extend to stock. If we wanted to see again, preview the chains, you can see right there. Moving on down, we're going to pick our 3/4 inch flat end mill, which happens to be right there. And let's just give us a comment. Machine top pocket. Let's look at our cut parameters. Now here's what the tutorial has us doing. It has us turning on corner rounding and leaving nothing on the walls and leaving nothing on the floors. So we're using this as a finish pass, but we're turning on corner rounding. This can work, but it can also leave stock in places that you don't expect it to be because this corner rounding is cutting corners. So depending on your tolerances, this is probably not a good idea. But then again, I would probably be leaving a little bit on the walls and coming back with a contour to clean anything like that up. So in which case I would be using corner rounding, but I would be coming back later to contour the walls. But we're going to sort of follow along on the tutorial on this. We're not going to leave anything on the walls, and we are going to turn corner rounding on. Depth cuts. This is an area mill. It's not a dynamic tool path. So we're going to set our max rough step to 1/4 inch with a 50 thou finish step. Entry method. The tutorial has us using an entry helix and setting it to 0.5. I do not like that we have a 3/4 inch tool. So if we set our radius to 1/2 inch, we're going to leave a boss in the middle as we're helixing down. And then we're going to have to machine that boss off, which is kind of a pain. So I'm going to set my entry helix to 0.37 so that I don't leave that boss. I might also just do profile ramp, which I kind of like. But for now, we're going to helix down at a 0.37 radius. Linking parameters. We're going to set our clearance plane to 1.0. Our retract to 0.5, our feed plane to 0.1 incremental. Top of stock is 0 absolute. Depth is going to be 0 incremental. Now this is important. We're using incremental for a reason because we're going to copy this tool path and change the geometry. So by having it set to incremental, it associates it with the selected geometry rather than an absolute 0 of the part. This allows us to copy the tool path, just change the geometry and reuse settings, and the depth will follow whatever geometry we select. Let's go ahead and preview the tool path. You can see what's going on there. Now let's take a moment and take a look at this tool path. I have said multiple times that area mill is an old tool path. There's really no reason to use area mill and that you should mostly use dynamic. This is sort of true and sort of not. It's certainly easier to program using dynamic, but let's compare the two tool paths and see the differences. You see an area mill, it's a nice predictive tool path. It just keeps going in predictive circles, or squares in this case, but it's stepping out, taking another pass, stepping out, taking another pass. And let's compare that to a dynamic mill and see what that same pocket, if we dynamic milled, it would look like. So we're just going to change that to dynamic mill right there. we can turn off depth cuts. Doesn't matter, come down, everything else should be the same. Take a look at this. Now look at that tool path right there. So what dynamic mill is doing is it's doing some flowy paths to keep from over engaging the cutter into the corner. It's coming around, leaving some material, and then coming back at a different angle to minimize cutter engagement. And this is what it does to allow you to use the full flute length of the end mill, and we don't have to do so many depth cuts. But what it does is it leaves kind of this flowy pattern on any floors that you're machining. Some people may not like those flowy patterns. It can also be a little bit slow when you could get by with an area mill. So let's go back and change it to an area mill. Now we see this tool path, and let's backplot this. And let's look at how long this tool path is going to take. So that's 5 minutes and 29 seconds. Now that's ridiculous. That's because we use the default settings in Mastercam for speeds and feeds. But we can still use it as a comparison to look at the time for an area mill versus a dynamic mill. So let's remember that, 5 minutes, 29 seconds. Let's go back to our parameters, tool path type. Now we're going to change that to a dynamic mill. Rebuild that, backplot that, look at our info, 7 minutes and 34 seconds. So 2 minutes slower to machine this pocket with the dynamic mill. Now, if we had to take multiple steps down with the area mill, if this was a 1-inch pocket, now dynamic mill becomes a big advantage because we could go all the way down and do one pass with the dynamic. But in these short pockets where using the whole flute length isn't advantageous, an area mill will be faster because it won't be going back and doing that flowy tool path around. So dynamic mill is a little faster for programming, but disadvantage is it can leave an interesting pattern on the bottom of the part that some people don't like, and it is actually slower in areas where you wouldn't be doing multiple depth cuts with the area mill anyway. So let's go back and change that to an area mill because that makes more sense. Rebuild that tool path so we can see it. And now we're going to use the same area mill to machine that bottom pocket. So let's just right click here, drag down to here, and say copy after. Let's drag our red arrow down so new toolpaths are created in the right spot. Then we can take and click on our geometry. We're going to change the machining region. Now we're going to be at the bottom of this pocket. So we need to say rechain all. Click down there. So there's a new pocket that we're going to be machining. That's good. Okay, but we need to go into our parameters. We're not going to get down there with a 3/4 inch end mill. We're going to go down there with a 5/8 inch end mill. Cut parameters, I think everything else can be same. We're not changing that. Depth cuts, oh, we need to turn depth cuts back on, 0.25. Transition, entry helix. This is not going to work on such a narrow pocket. We're going to change this to profile ramp. It's going to save us a lot of time, and we wouldn't be able to helix down there anyway. Linking parameters stay the same, 0 incremental, so that we machine this pocket here. And let's preview that. Notice how it's following the profile of our pocket all the way down as it's going down. Okay, so that's roughing in these two pockets with a 3/4 and 5/8 end mill. So let's go ahead and copy these two. And we need to finish these with a smaller end mill so that to get, for example, these corners in areas where the end mills wouldn't be able to get in. So we have both of these selected. And I'm going to right click, drag to the red arrow, let up, and say copy after. drag our red arrow down. So let's go ahead and modify this first one. The chain is going to stay the same. The geometry is going to stay the same. But we're going to come up here and we're going to change our tool to 3/8. And now we're going to use this stock parameter. We haven't used this stock parameter much. So we're going to turn on rest material. And what this is going to do is it's going to remove material that was left behind by another operation. If you select all previous operations, it will be huge. It's going to take a ton of time. The computer is going to have a really hard time doing that, and the more toolpaths you add, the harder it's going to be because it's going to keep analyzing. So what we want to do is select one other operation and just select that first toolpath because that's the pocket we're working with. Everything else pretty much stays the same. Corner rounding is going to stay on. Let's turn corner rounding off so we can get into those corners. We're only going to be doing a little bit right over here. Linking parameters stay the same. I think everything's going to stay the same. Entry helix. Let's take a look what that looks like. Yep. So we're just going to come in and clean up these corners where the other end mill couldn't make it. And now let's do the second one here. Parameters, tool, 3/8" flat end mill, turn on stock, rest material, one other operation, second operation, everything should stay the same. See what that looks like. So there again, coming in, we're doing 3 passes in each of these corners. Not optimal. I think a dynamic mill or a contour going to full depth would make that look better, but this is going to work and it's going to give us our part. The green checkbox out of there. Off we go. So now we need to drill these 4 holes. Drilling toolpath. Let's unpin that so we can get a little more room in here. There's a little cursor that shows center of hole. Click on that. You're going to come over here. You want to see the cursor showing the center of that arc. Come over here. Boom. So let's see. If I were to click right there, notice it clicks on the side of the part. I have to wait until I see center of hole. So I'm now going to click there, like that. And now I'm going to go in and delete my hole 4. I'm just hitting the delete key there to get rid of that mistake hole. So now I have 3 holes. 1, 2, 3, 4. Good to go. Okay, and let's look over at our tutorial and see what size drill we're using. I'm assuming because we're going to start out by spot drilling the holes. So that means our tool is going to be our 3/4 inch spot drill. Cut parameter is going to be drill counterbore. We're not going to dwell. Let's go back and give it a comment. We're going to have to go back and add some comments to the other one since I forgot to add comments and since I copied toolpaths. I have some bad comments in toolpaths, which would be really confusing for the operator. Spot drill the 4 holes up 1. Okay, so let's go down to our stock. Make sure use stock is not selected. Cut parameters, drill counterbore. Linking parameters. All this is good except for our depth. Since we're spot drilling the holes, we just want to spot drill the hole and create a chamfer on that. Hole's going to be 9/16 plus a 50 thou chamfer. So we're going to use our depth calculator here. And up here for finish diameter, we can just use Mastercam's math functions and say 9/16 plus 0.05 for a little bit of chamfer. And we're going to overwrite the depth, which gives us that depth. And there we go. Let's go ahead and preview that toolpath and see how it looks. Looks about right to me. Okay, let's bring our toolpaths back out here and pin them. So we're going to need to be using them. So we spot drill those holes. So next thing we're going to have to do is drill them to depth. So let's go ahead and just copy this down to here. Move our line down here. Now open up our parameters. We don't need to change the geometry. We're using the same 4 points. Go to our tool. We're going to use a 3/32 drill. Okay, cut parameters. Let's peck drill this. Let's use 1/4" pecks. Linking parameters. We're going to drill these to depth. So let's just hit the depth button here. Click on the bottom of our part. So I could go -1.5". Let's change that to absolute. Doesn't really matter, but we're going to change it to absolute. Okay. And tip comp, we want this to come all the way through. So we're going to come here, breakthrough amount. Let's just go to 0.1. Make sure that tip gets nice and clear. Okay. Rebuild the toolpath. Make sure it's going all the way through. Yep, it's going all the way through. Okay, so now we need to tap these holes. So once again, let's copy here, copy after, bring our red arrow down, parameters for this. Tool is now going to be our 9/16 18 tap. Tap the 9. Change that to a tap. Linking parameters, this can change, this can stay the same. Tip comp, notice the change in our tip angle, but our breakthrough amount is the same, so that's all going to work just fine. Rebuild that toolpath. Okay, so there are all of our toolpaths for OP1. Let's go ahead and verify those and see how they look. So a couple of things, stop conditions. I'm going to stop on operation change so I can watch it go through on each one. Click verify. I'm going to say see color loop by operation. Oh, I didn't have all my toolpaths selected. Okay, so there we go. Click on OP1, select all of our OP1 toolpaths. Verify. So we got our color loop going on. Our stop conditions are by operation change, and we can watch this cut. Okay, looks good to me. We got them all.